Multiplication and division are inverse operations. So are addition and subtraction, and squares and square roots, which you have worked with extensively. It makes sense that graphs would have inverses too. A relation is a rule that connects one set of values, the domain, to another set of values, the range. A function is a relation that relates each element of the domain to a unique element of the range. Inverses find the root cause of an effect or change. In other words, you can work backwards and find a rule that relates the range of function to its domain. The inverse of a function undoes or reverses the effect of a function. To find the inverse of a function, you can work out a rule that works from the range back to the domain. This rule describes the inverse of the function. If you know the function f of x, you can use these steps to work out the inverse function. First, let's write f of x as y. In other words, replace f of x in the formula with y. Second, swap the x and the y in the formula. This step is important. What you are doing is interchanging the domain and range. The effect is that the domain of the function becomes the range of the inverse function, and the range of the function becomes the domain of the inverse function. Lastly, make y the subject of the formula. Remember, when a function is inverted, the domain and range are interchanged, and when a function is inverted, the x and y coordinates of the intercept are interchanged. Now, we can apply these rules to an example. For each of the graphs sketched, state whether the inverse graph will be a function or not. Give reasons. In part 1, we are given a graph of a parabola. It is a function because there's only one y value for every x value. It is a many-to-one function. What does the graph of the inverse to this parabola look like? Choose some points on the graph. Let's choose 0, 0, -3, 3, and 3, 3. Swap the x and y values around. When you plot the new points, you can see where the graph lies. 0, 0, 3, and -3, 3, and 3. You can also find this graph by reflecting the original graph about the line y equal to x. Is the inverse graph you have drawn a function? Using the vertical line test, we can see that it is not a function. It is a one-to-many relation. Let's look at part 2. This is a graph of a circle. If we find the inverse using the reflection about the line y equals x, we get an inverse graph as shown. You can check the accuracy of the graph using by reflections of the points A, B, and C on the original graph. Is the graph of the inverse a function? No, since the original graph is a many-to-many relation, therefore the inverse will not be a function. And now to work out if part 3 is a function. You can reflect the graph over the line y equals x or swap the x and y coordinates of the points on the graph. You will recognize that the inverse is a graph of a parabola and it is a function. It is a many-to-one function.